All right, lesson 27. We're going to talk about inverse today. The reason we're talking about inverse is because that's going to transition us into logarithms, which is coming. Not this lesson, the next one, I'm going to start talking to you about logarithms. But we have to first understand what an inverse is if we're going to understand a logarithm. So the inverse of a function is basically a function that does the opposite of what that function does. All right. Now I'm using the word function. We haven't talked about that in a while, but a function, of course, is just an equation. Basically, like y equals 2x is a function, but in function notation, it's written as f of x equals 2x. So there it is in function notation. So a function's inverse is a function that does the opposite of the original. By the way, before I forget, can you guess what's in the background today? I'll get back to that. So I have this function, f of x equals 2x, and I want to make its inverse, which is going to be a function that does the opposite of the original. So what's the opposite of taking a number and multiplying it by 2? Because that's what you're doing here. 2x is 2 times your x values. Well, the opposite of multiplying your x values by 2 is dividing them by 2. So if I wanted to find this function's inverse, it's simply going to be the opposite. It's going to be my x value divided by 2 instead. Now, how do we write that notation? What we do is we take our f of x and we just put a little -1 in as the exponent, and that indicates that we're finding the inverse of that function. So the opposite of multiplying by 2 is dividing by 2, so we have found that function's inverse. Now I'm going to show you how to do this with algebra here in a second. I'm just trying to keep it simple at first. Let's go over here. We got y equals x over 3. So that's x divided by 3. Well, in function notation, that is f of x equals x over 3. Either way, the opposite of taking a number and dividing it by 3 is to take a number and multiply it by 3. So the inverse of this function is going to be taking our number and multiplying it by 3. So it's going to be 3x. That's how inverses work. Now, it doesn't mean it will, no, let me rephrase. If the original function is written in y equals notation, you don't have to write your inverse in inverse notation and function notation like I've done here. You can simply just state what y is equal to, and I'll show you that here as I go through the examples. All right, so I'm going to show you what I mean by you don't have to use function notation. And again, this background right here, have you guys figured out what this is yet? It's someplace close to us. Talk about it in a few minutes if you don't know what it is. So let me show you an example here. So if I give you the function y equals 3x plus 5, and I ask you to find this function's inverse, which is the equation that does the opposite of the original. Now, this original equation is not in function notation. So if it's not in function notation, you don't have to write your answer in function notation. You can just leave it in these terms. So how do I algebraically do this? Well, let's look at the original here. We have plus 5. The opposite of that is minus 5. We have 3 times x. The opposite of that is x divided by 3. So we know we're going to have division by 3 and subtraction of x in our final answer. Now, you can do that in your head, but let me show you how you do that with algebra. So the first thing you want to do is you want to switch x and y. You want to flip-flop. So what I'm going to do is I'm going to take my y value, make it x, but take my y value, or x value, make it y. So I have x equals 3y plus 5. So I've just flip-flopped the x and y, and this is going to create those opposites that we're looking for. Next, I want to solve for y. I want to get y by itself, so I get it back to the original form that it was in when we started from, y equals whatever. So to do that, I got to do some manipulation of my equation. It's just some simple algebra here. So let me erase this part here for a second and just show you that simple manipulation. To get y by itself, I need to subtract 5 from both sides. So when I do that, those cancel. I get x minus 5 over here because I can't actually subtract x and 5 because they're not like terms. And then I equals 3y. And then if I divide both sides by 3, there it is. I found out that y is equal to x minus 5 over 3. Now, if you don't like having the y on the right-hand side, you can switch that to y equals x minus 5 over 3. There is the inverse of that function. And we said it. We said there was going to be division by 3 and subtraction of 5. And we got both of that in the answers. So there it is. There's the inverse of this function. Now, like I said, you don't have to put it in function notation, but if this was in function notation to begin with, we could simply, switch this to a y, no problem, just say, you know what, we're going to call this y, and flip-flop, solve, get it all done, and when we're done, just change this y right here to f inverse of x, just using inverse notation. F, little negative 1 exponent for inverse, and we're good. So it's not a big deal whether it's in function notation or y equals notation. It doesn't matter. Either way, you just got to flip-flop your x and y and solve. So let me do one more with you. Do you know what this background is yet? Before I do our last example, have you figured out what's back here? This is Watkins Glen State Park. It's the gorge, and if you have never walked the gorge in Watkins Glen, it's really cool. I have done it several times. What's interesting is, not to get all earth science on you, but you have all this sedimentary rock here. You can see all the layers. It's pretty cool. It's a neat walk. It's good exercise. It's fun. Something to do in these boring times. So, maybe that's something you want to do. Go up to Watkins Glen State Park, walk the gorge. All right, last example. So I have a function that's actually in function notation. F of x equals 2x minus 1, and I want to find its inverse. Now, to find the inverse, we said we have to switch the x and y value. But oh no, there's no y value. Well, there actually is, because remember, f of x and y are the same thing. So what I would do is, if you have something that's in function notation like this, the first thing I would do is just switch that to a y. There, it's y equals 2x minus 1. Then do what I said in the previous example, flip-flop your x and y, so you got x equals 2y minus 1, and now solve for y, get y by itself. To do that, I would have to add 1 to both sides, and I get x plus 1 over here equals 2y. Divide everything by 2, those cancel, and I get y equals x plus 1 over 2. For those of you that like the y on the left side, y equals x plus 1 over 2. Now, if the original equation was in f of x notation like this one was, you would have to go one step further and say that f inverse of x equals x plus 1 over 2. And that would be your final answer, because the original equation was in function notation. If the original equation is not in function notation, it's just y equals like our other ones were, you can stop right here. This would be good. All right? So that's it. That's just the basic idea of finding a function's inverse. Switch the x's and y's, solve for y, get y by itself, and you're good. And that's how you find a function's inverse. Now you might be thinking, okay, what does this have to do with anything? This is really random. This has nothing to do with exponents or anything like that. this is how I'm going to introduce a logarithm to you. So I have to teach you the idea of an inverse first so that you can see how a logarithm works, because logarithms and exponents are inverses of each other, and we need to understand the concept of an inverse first. That's the reason. All right.